11.6, use normal distribution, and we're going to use this to interpret data. Let's take a look at a bell-shaped curve. There are certain sets of data that when you graph it, they're symmetrical with a single central peak at the mean, and the shape of this curve is described as bell-shaped. So even in its histogram shape here, it is looking like a bell. So what we understand is 50% on one side represents half of the data, and the other half of the data is represented on the other side. What's interesting about this normal curve is that the mean, median, and mode are the same in the normal distribution. So here's the mean right here. It will also be the median and the mode. They are all the same. Okay, so normal distribution is a very important statistical data distribution pattern, and it occurs, it's a natural phenomenon, and it occurs for human heights, blood pressure, IQ scores, things that describe a lot of situations. And we have this bell-shaped curve that describes the data. Not all data is normally distributed, so a simple test to see if it's normal is to make a histogram. In this case, we have some test scores and the number of people who scored, and you can say this is not a bell-shaped curve like we had before. So not all data is normally distributed. Let's take a look at what a normal distribution may look like. The mean, it can be anything, and the deviation can be anything, standard deviation. If the standard deviation is small, then that means that the data is all clustering around very close to the mean, and if the standard deviation is wide, that means there's a widespread. Now the mean we will now start calling as mu. Okay, let's take a closer look at the shape of this normal curve. Notice that from here to here, it looks like it's curving up, and then from one standard deviation to the left to one standard deviation to the right, it looks like it's curving down and then curving up. These places where it changes its curvature are called points of inflection. They are also one standard deviation from the mean. What's important to note is that in a normal curve, the total area under the normal curve is 1. And so what we do is we find the areas underneath these curves. It represents the area, and it also represents the percentage of data that's in there. So one standard deviation on both sides of the mean represents 68% of the data, or you can cut it in half, 34 on one side, 34 on the other side. Two standard deviations from the mean represent 95% of the population. And so if we were to take 95, subtract 68, and then divide it by 2, we're going to get 13.5, and we'll have 13.5 on this other side. So from here to here, you're going to get 95%. And then 3 standard deviations is 99.7%. So let's take a look at doing a problem on something that's normally distributed. The ages of the employees at Google are normally distributed. Within this curve, 95.4% of the ages are centered about the mean and are between 22.6 and 35.4. Well, 95% is 2 standard deviations from the mean. So here is the mean and 2 standard deviations. That would be 22.6 and 35.4 represent 95.4%. We want to be able to find the mean, and finding the mean would mean to find the middle of that. So we're going to take the average of 35.4 plus 22.6, add them up together, and then divide by 2, and we're going to get 29 as our mean. So our mu is 22.6 plus 35.4 divided by 2, and that's how we get that. Now we'd like to figure out what the standard deviation is. So I'm going to subtract 35.4 minus 29, and I'm going to get 35.4 minus 29, and I'm going to get 6.2. Now that represents 2 standard deviations, so 6.2 divided by 2 will be 3.1. So the standard deviation, which is sigma, will be 3.1, and the mean, which is mu, will be 29. Let's take a look at another problem. The amount of time a trainer spends with a young elephant is given is any given week is normally distributed. The trainer spends an average of 12 hours per week. So we know mu right here. That's going to be 12 hours per week with a standard deviation of 3. So we're going to go over 3. That'll be 15, over 3, 18, and so on. This way it'll be 9, and over 3 is 6. So what is the probability that the trainer spends 12 to 15 hours? 12 to 15 hours. Let's figure out what this percent is, and whatever the percent is, that is also the probability. And so here we are right here. This is one standard deviation on both sides is 68. So this will be 34%. We're going to change that to a decimal. The probability from 12 to 15 hours is going to be 0.34. That's a probability that it'll be with the elephant. Let's take a look at our next problem. A litter of 12 puppies arrives at a shelter for adoption. Show that this data is not normally distributed. Okay, so we're going to go to our calculator, and I have entered all of the values for the weights of all the puppies here. And the way to check to see that if it's normally distributed is to actually graph a histogram. So I'm going to go second, plot, and I'm going to turn this on, and and then I'm going to go down here and I'm going to pick a histogram. Now I want to make sure it's on list 1, and list 1 is right here. Second, and then I'm going to press key 1, and it's list 1. Then I'm going to do zoom, and I'm going to do zoom stat, which is 9, and then enter. And then I have that. And you can see that's not a normal distribution. So I've done part A. Now we want to find the mean and the standard deviation. We can let the calculator do that. Second, quit. And I'm going to do stat, go over to calculate. I'm going to do one variable stats. And I'm going to do it on list 1. So I second 1. So now it's on list 1. Go down to calculate, and I'm going to have enter, and I'm going to be able to see that the mean is 5.483 and that the standard deviation is 0.498. Okay, so let me go ahead and write those values in here. So my mean, mu, is 5.483, and my standard deviation, which is sigma, is 0.498. So I found the mean and the standard deviation. So part C, what is the percent of the puppy that weighs more than 1 standard deviation? And so what we want to do is we want to take our average and add one more, 1 standard deviation. So that's 5.483 plus 0.498. And when I add those up, I am going to get 5.981. And I want to find the percent of the puppies that weigh more than 5.981. Okay, so let's see how many that'll be. This one, and this, and this, and that's it. So it looks like the number of puppies will be 4 out of the 12 puppies. And 4 out of 12 puppies is going to be a 1/3 or 33 1/3%. That's the percent that are more than 1 standard deviation. Okay, the next one, I'm going to use the next slide. And the question says, what percent of the puppy weights should have been more than 1 standard deviation above the mean? Okay, so remember that the mean was 5.483, and if I want to go over more than 1 standard deviation, to have way more than percent would have been more than 1 standard deviation above the mean. So in other words, I want all of this percent here. And this is, remember, 34%. And this over here, remember, this is half of it. So the rest over here is going to be the rest of 50%, which is 16%, because 16% and 34% add up to half, 50%. So if it had been a true standard deviation, it would have been 16%. But remember, we had, because it was not standard, I mean, it wasn't a normal curve, it was 33 1/3%. Your turn. Here's the answer. Remember that in a normal distribution, all three are the same. Your turn. And here's the answer. 68% means 1 standard deviation to the left and to the right, which would mean 10 to 20.